All right, y'all, we're going to talk about some types of data storage for this DP900 exam. So there's a lot to get to, so we're going to try to get to this real fast. Some of the stuff that I saw on the exam that you'll need to know so that you can ace this and not fail it multiple times like I did. So you have this Azure SQL database, which is that relational database that's ACID compliant, that atomicity, consistency, isolation, and what is the last one? All right, everybody, welcome back to the channel. I am Wheatstraw, and today we're going to talk about the DP900 Azure Data Fundamentals exam. It is an entry, beginner level exam, but don't let that fool you. It is very difficult. I am not sure what it is about this exam and why I suck at it so bad. I failed it multiple times. I just have a blind spot to it. I do not know what's going on, but that's okay. I'm going to help you all. And you all are going to pass, and you all are going to do great, and I'm going to suck, and that's okay. That's okay. So the exam for me is an hour long, 45 questions. It focused on some areas we're going to talk about, but you know, it really isn't too bad, except I just can't do it for some reason. I just wasn't able to do it. Took so long to get through this exam. So let me help you. All right, y'all ready? I'm ready. Let's go. Okay, first up we have ACID, A-C-I-D. Now this is really important. So this is an acronym. It stands for atomicity, consistency, isolation, durability. You're going to see several questions like this, and I got many of them wrong because for some reason in my head I can't do it. Anyway, atomicity is this idea that it's all or nothing. So a transaction must complete fully or it will fail, fully fail. So if any part fails, the entire transaction is rolled back. That is atomicity. So it'll prevent a kind of a partial write. So really important for, you know, like a financial system or inventory system. So all of it has to work or none of it works. Consistency. So after that's the next one. After a transaction, the database must remain in a valid state. All the constraints, triggers, foreign keys, data types, all of it's valid. There's no corruption and no rule violations or anything like that. So the data is consistent. So isolation, meaning there's no interference between transactions. So, you know, concurrent transactions, like they won't affect each other in like intermediate states. So as they're happening, so one transaction happening here on an account, another transaction happening here on an account, somehow won't fail something and break something and, you know, ruin everything. And there's errors and things are broken and all that kind of stuff. So isolation, no interference between like different transactions happening at the same time. And then you have durability. So that just means, hey, does something survive a crash? Once the transaction is done, is the data saved permanently? So that's really important. And so remember durability, isolation, consistency, and atomicity. Remember those. You're going to get several questions right. And it may ask you different commands, SQL commands that apply to ACID. So I think there's rollback is one of them. I know rollback's one of them. Commit is one of them. And begin transaction, that's another one. Yep. So though you see those, any of those three, that's usually connected to ACID. They may try to ask you some tricky questions like, you know, which one of these is an, you know, blah 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 kind of transaction or you know, command in SQL. So atomicity, consistency, isolation, durability, ACID. Remember that. Let's go. All right, so the biggest area, I think, in DP900, where you can get the most correct answers if you know kind of these concepts, is about the differences between relational and non-relational databases. So a relational database is structured and schema-based. It uses tables and rows, you know, columns and fixed schema. It enforces relationships through keys and constraints. You know, it's ideal for transactional workloads, you know, that require predictable structure and strong consistency. So remember that relational databases structured, schema-based. Non-relational databases are flexible. The schema is optional here. So, you know, they store data like documents, formats like documents, and, you know, key value pairs. That's really important. Remember that. That's for non-relational databases. Graphs, column families. High scalability is really important here. rapid development, and all kinds of different data can fit in these non-relational databases. So it captures a lot of everything. So remember that. So in non-relational database, that's Azure Cosmos DB. Remember that. Just non-relational database. That's what you want. That's what you want to do with Azure Cosmos DB. So there's this structured query language. That's the SQL versus the NoSQL. The SQL is relational. The NoSQL is for Cosmos DB, that kind of thing. So remember those things. Scalability, so relational databases, they scale vertically. Non-relational databases scale horizontally. So, there are more nodes in non-relational databases. There are more servers in a relational database. So, for a relational database, like I'm trying to think of some examples that will be good for that. So, like electronic records keeping, HR systems, financial systems are good for relational databases. Really important. Anything that requires like a complex transaction and strict integrity, that's good for relational databases. So non-relational databases, social media feeds, really important. That's going to be an example they use. That's a non-relational database. Product catalogs, Internet of Things, telemetry, those kinds of things that require flexible schema and require low latency. You want to use a non-relational database. So remember, so think about it. So for relational data, what Azure offers, you have Azure SQL database, you have the managed instance, you have the SQL server on VM, and you have Azure database for Postgres and MySQL. So for a non-relational database, remember that's that Azure Cosmos DB. So that's that document data, the key value pairs, the graph, column family, and the Azure table storage, which again is that key value data. So that's non-relational. That's non-relational data. That's relational data is the SQL database, that managed instance, and the SQL server on the on a VM. So really important. You get those two concepts right, you're going to get a lot of questions right on this exam and pass the test, unlike me. All right, y'all. So we're going to talk about some of the different types of storage that you're going to see on this DP900 exam. There's a lot of different things we're going to talk that go in this category, but I'm going to try to tell you all the things that I saw in the exam so that you can get them right, because I sure enough didn't. Okay, so we have the Azure SQL database. That's that relational database that's ACID compliant. It's fully managed relational database for structured transactional kind of workloads. It's ideal for OLTP systems and systems that require strong consistency, and you want to do complex queries. There's this Azure Cosmos DB that can do NoSQL or is globally distributed. So it supports document data, key value data, graph data, and that column family data. So it can do, there are different kind of consistency levels that you can do with Cosmos DB. There's a lot. It's actually really cool. Global replication, massive scalability, and so it's really good for if you have something like globally distributed apps. Really good for like a Twitter kind of thing. But that's don't get me started. So Azure Blob Storage, that's this, it's great for unstructured data. It's the one you're going to hear about the most, like images, unstructured data like images and logs and backups and binary objects. Remember that there are three tiers supported for Blob Storage. There's this hot tier, the cool tier, archive tier. Hot tier, you can access it quickly. Cool tier, you can access it less quickly. Archive tier, you have to wait. You may not necessarily get to access it quickly. So that, hot, cool, archive, and it's just about how quick you can get to the data, and you can cost optimize for that. Archive is the cheapest if you don't need data immediately. So remember that. Table storage, it's simple, it's scalable. You can do for semi-structured data. There's no schema, no relationships. It's good for fast lookups. It's cheap. You can do logs, metadata, all sorts of stuff like that. Azure Files, I'm sure you've heard of that. This is the SMB and the NFS protocols. Just think about that. Just remember for Azure Files, SMB and NFS. So, you can do the lift and shift kind of scenarios. What else can you do with it? blanket on. So, you can do for shared storage is great for shared storage and VMs and all that global secure access stuff. Don't get me started on that either. There's also disk storage. There's Azure Disk Storage. It's those persistent disks attached to Azure VMs. That's really all you're going to need to know about that. Data Lake Storage Gen 2. That's the hierarchical object storage. So it's built on blob storage, but it has a hierarchical namespace. Remember that a Data Lake supports that hierarchical namespace. So it's optimized for big data workloads, Spark, Databricks, ideal for large-scale analytics and pipelines, things like that. What else? Azure Synapse Analytics. That's the analytical storage. It's distributed columnar storage for data warehousing. So massive parallel processing, that MPP stuff, and optimized for analytical queries. You use it in Power BI reporting and like enterprise size analytics. So remember those types of storage. You're going to get like all sorts of miscellaneous questions around those. You can get several of those right with this information here. All right, let's keep going. All right, so the next thing we're going to talk about is data normalization and a little bit about normal form. So really for this exam, what matters around normalization, you need to know that normalization, ensures databases, relational databases are storing data, correctly or efficiently. It reduces redundancy and it helps with data integrity. So really important because you don't want there to be any problems when you're inserting data or deleting data or making an update somewhere. So normalization helps with that. So there are different types of normal form. The first two in all my studying and everything I've seen and Microsoft Learn, their first two are what matters, the first normal form and second normal form. First normal form requires data be atomic. So what that means is it's not divisible. It's not repeating, and it's uniquely identifiable. Really important. So there's no fields that have like more than one value. That's really important in first normal form. Second normal form, it's a composite of primary keys. It's all, that's the best way I know to explain it. So basically it eliminates dependencies, partial dependencies, and reduces redundancies, in many to many relationships. So really it's, you got to know, just think about atomicity and think about, for atomicity for first normal form, and think about second normal form just being tables with composite primary keys. Just remember that. I think that's as far as you're going to need to go with normal form. But remember data normalization, why it's important. You won't have any anomalies or anything when you're deleting data, updating data, and inserting data. So data can be normalized and denormalized. That's important. So normalization improves integrity. Denormalizing data, that can improve performance. So I didn't have any questions about what denormalization does. I had questions around what normalization does. So it improves data integrity. Remember that. Normalization, first normal form, second normal form. Let's go. All right, so I want to talk about several services in Azure that they're going to ask you about on this DP900 exam. The first is a data lake. I'm thinking about the data lake is where you just dump all of your raw, unstructured, and semi-structured data. It could be like logs and images and CSV files, things like that. You just dump it all here. It's low cost. It's kind of this place it sits before you move it on elsewhere. So it's just the place you dump it. Like I said, it's very scalable, low cost storage. You put it all here before you do something with it. Data warehouse. Think about this is where you put all your structured, your curated data, the data that's been cleaned, that's about to be optimized for analytics. So this is the data you're not going to touch when you're about to do your analytics, that kind of thing. It uses columnar storage and that MPP, that what is that? Massive parallel processing, for like a really quick aggregation. So it's ideal for Power BI reporting, dashboards, and enterprise level analytics. So that, remember that. So a data factory, that's the, you think about it's this data ingestion and pipeline orchestration. Really important. So think about it like, and you need to think about a factory. Think about all the things that happen in a factory. Is that all these parts are moving, putting things together, and pushing it out. Like that's this movement and transformation. And they're going to ask you questions about where's data go to be transformed? Where does it move through, to be transformed? And they're going to say pipelines, and that's when they're talking about a data factory. So remember that. Finally, this Power BI. It's just visualization and analytics. So there are different types of, your dashboards are really important. You can do reports and data modeling via Power BI, and just how you view the data, how you see the data, that you do that via Power BI. So just know that's important. They all kind of work together. So think about it. So a data factory ingests the data lake stores the raw data, the data warehouse curates the data, curates analytical data, and then Power BI, it visualizes the data, visualizes the insights that have been, curated in the data warehouse that was, dumped into by the data lake, the raw data, and all that kind of stuff. So it kind of all flows together. So, it's dumped here, processed, and comes out in Power BI in ways that folks like us can understand. So remember those things. You'll get several questions right. You'll pass this exam. All right, so in this section, I'm going to hit you with two important concepts and something that's going to be random, but I want to make sure I include in this video. So the first thing is this OLTP, this online transaction processing. It's designed for fast, small, frequent transactions. So some of the commands you're going to see is an insert command, the update command, the delete command. So this OLTP prioritizes ACID compliance with low latency and high concurrency. So an Azure SQL database is the primary OLTP service in Azure. So remember that. OLTP, it's highly normalized schema. You do small queries, very strict consistency, and row level type operations. So important, just great for business apps like banking apps, retail checkout, inventory, user account systems. That's when you're going to see the online transaction processing. Now, the other one, I saw more questions about OLTP and fewer about this one, which is OLAP, OLAP. That's the online analytical processing. That's for complex, the large scale analytical queries, and with huge data sets. So it prioritizes read performance and aggregation. And so where you're going to see that the most, you're going to see that in Azure Synapse Analytics. That's going to be the thing that does the OLAP, online analytical processing. So the biggest difference between those two, transactional. OLTP is transactional. It's normalized, and it rows. It's very row oriented. So OLAP, OLAP, it's analytical, column oriented, and it's denormalized. And it's optimized for scans and aggregates, large data pools. So remember that. Okay, and finally, and this is random, but I got to include it. So indexes. You're going to see questions about an index. What is an index? It basically is something that improves query performance in a database. So you can query something difficult, but it's already indexed, and so you're going to get it faster, because some of these queries can take forever, and it's ridiculous. Like some queries can take all day. It's really quite weird. Data is really funny like that. So just remember what an index is. It helps with queries, slows that process down, or speeds that process up, excuse me. And remember OLAP and OLTP. All right, you're done. You got this. We got this. You're going to go out there. You're going to pass this exam. You're going to come back. You're going to tell us how you did. Don't forget to like and subscribe, and I'll see you on the flip side.